So in this lesson, we're going to talk about the conics. And to get started and have a general discussion about what the conics are, we'll start with a cone. Looks something like this. And we'll take a plane that's going to then intersect or cut through the cone. The trace or the impression left on the plane from the outline of the cone, that's going to be our conic. Now there are four different types of conics that we're going to talk about. The first one will be the parabola. The second one, the ellipse. The third one will be the circle. And the fourth one, the hyperbola. So those are the four conics that we'll talk about, and we'll handle them all pretty much the same way, where we'll start with the definition. I'll give you the equation for the conic. I'll set up a picture and show you where it all comes from, and then we'll look at some problems. So to get started, we'll talk about the parabola. The definition of a parabola is the set of points in a plane equidistant from a fixed line. That fixed line is called the directrix, and a fixed point called the focus, and that fixed point is not on the directrix. So there's the definition. The equation of the first type of parabola that we're going to study would be the y equals a x minus h squared plus k, where the vertex is the point hk, and then I'm going to leave a blank. All of these conics will come with secondary formulas, and I'll come back and fill in that blank with the parabolas, the secondary formula, here in just a minute. I also do want to remind you that if a is positive, the parabola will open up, and if a is negative, then the parabola opens down. So let me go ahead and sketch a picture now and show you exactly where all of this comes into play and how it's all related. I'm going to go ahead and clear the screen to do this. So we'll start with our picture here for y equals ax squared, with a being bigger than 0. And I'm going to try to draw this pretty big so that it doesn't look too bad when I get it all marked up. So here's our xy plane, and the parabola that I have written on the screen, the y equals ax squared with a being bigger than 0, just implies that we are looking at this type of parabola right here. Now the focus that I mentioned in the definition is going to be somewhere like that, and the directrix will be somewhere like that. Now we're going to define the distance between the vertex and the focus, and also the distance between the vertex and the directrix as distance of p. So that's a p and that's a p, which essentially then means that the vertex is always going to be halfway between the focus and the directrix. Okay, so if we call that distance p, this point would be the point 0 p, and this directrix down here would have the equation of y equals negative p. Now the definition for a parabola states that the set of points in a plane, remember that's the plane intersecting the cone, equidistant from a fixed point, equidistant from the focus, and equidistant from the fixed line, the directrix. So what that means is when I draw this picture, that even though my picture isn't the greatest, D1, by definition, D1 equals D2, okay? So what I think I'll do is I'll go ahead and we'll call this point XY, and then this other point down here would be X negative P. So you can see that would be a 90-degree angle. If I came straight down, my X coordinate would be the same, and then my Y coordinate on the directrix would be negative P. So if we take the definition and we take these 3 points, 1, 2, 3, And if we put these together using our distance formula and set them equal, we should be able to learn a little bit about this parabola. So I'll start with D1. So using the distance formula, I'm going to have x minus 0 squared plus y minus p squared. So that's D1 right here. D2 now would be a square root of x minus x squared plus y minus a minus p. So that's going to turn into a y plus p squared. Now, to clean it up, we'll start by squaring both sides. The radicals now go away, and I'll expand out the y minus p squared. So that's going to be a y squared minus 2py plus p squared. And on the right, the x's go away, and we're left with a y squared plus 2py plus p squared. Now, some of this goes away. Y squareds are on both sides. P squareds are on both sides. So we have x squared equals 4py. Now, remember, we're trying to work with this thing. So if I take this step here and I divide by 4p, I get y equals 1 over 4p times x squared. Well, that is this equation right here when a is 1 over 4p. And so that's that secondary formula. You'll want to go back in your notes and fill that in. The a value for these parabolas is going to be equal to 1 over 4p, where p is the distance, again, from the vertex to the focus, which is also the distance from the vertex to the directrix. So we have a pretty good working knowledge now of the definition of a parabola and how it all relates. Let's take a look at a couple examples.